Welcome to another lesson of Math 0420 Introductory Algebra. In this video, we will be discussing stats number 4, organizing and representing data. In this section, we will be discussing Pareto charts, pie charts, the 5-number summary, and box and whisker plots. Let's start with a definition. Definition. A Pareto chart is a vertical bar graph in which the height of each bar represents frequency or relative frequency and the bars are in order from highest to lowest. Example 1, we want to create a Pareto chart for the data from stats number 3, example 4. So I've brought in the table from stats number 3, example 4, where we have ages in categories of 10 years and then their frequencies. Okay, and so for creating a Pareto chart, our various bars are going to be from highest to lowest. So we need to figure out the age ranges from highest to lowest. So we can order those. The biggest one looks like it's 40 to 49 because there are 11 there. And then 30 to 39 because there are 10 there. Next one looks like it's 50 to 59. And then 60 to 69. And then 20 to 29. And finally 70 to 79. Okay, and then we can draw bars with the height being the frequency. So the height of 40 to 49 is 11. We can draw a nice bar there. And then for 30 to 39, our height is 10. For 50 to 59, our height is 7. For 60 to 69, our height is 3. For 20 to 29, our height is 2. And for 70 to 79, our height is 1. And that is how you create a Pareto chart based on a given frequency table. Let's now move on. Pie charts. Let's start with a definition. A pie chart or circle chart is a type of graph representing data in circular form with each slice of the circle representing a fraction proportion or percentage of the whole circle. Example 2. A teacher conducts a poll to determine his 28 students' favorite color. The pie chart below shows the results. What percent of the class chose yellow as their favorite color? So the first thing we want to notice is that this pie chart represents students' favorite colors. And we see that the piece that is red represents red as a favorite color. The piece that is blue represents yellow as a favorite color. The color that is brown represents black as a favorite color. The orange color represents those who have blue as a favorite color. And the purple section represents white as a favorite color. So the colors of the circle do not necessarily indicate what they represent. So always look over here to the legend or the key to find out what it really means. So what is our total for our proportion? Well, our total is 28. And how many students chose yellow as their favorite color? Well, yellow is the portion that's blue, and 2 students chose yellow. So our percent is part over total times 100%. Okay, so that is 2 over 28 times 100%. And when you do that math, you get 7.14%. So 7.14% of this teacher's students chose yellow as their favorite color. Example number 3. What percent of the daily calories comes from lunch according to the pie chart below? Notice again that we have different colors representing different pieces of the pie chart. The blue section represents lunch, yellow is dinner, green is snacks, and red is breakfast. If we add all of these numbers up, 525, 360, 225, and 890, what do we get? Well, our total calories are equal to 2,000 total calories. Our lunch calories from our chart tell us that we have 525. So again, we have part over total times 100%, which is 525 out of 2,000 times 100%. And when we do that math, we get 26.25%. Okay, let's try one more example. Example number 4. Financial planners suggest a budget similar to that shown in the pie chart below. Answer the questions that follow. Part A. What is the total of the percentages on the graph? So what we can do is we can add these percentages, 31 plus 6 plus 7 plus 8 plus 8 plus 14 plus 26. And when we add all of those together, it's the total pie, so we get 100%. Okay? Part B. What is the total percentage spent on debt, insurance, and taxes? So the debt is 6%, insurance is 7%, and tax is 14%. So when we add those together, we get 27%. Okay, one last part C. A person makes $10,000 per month and has a mortgage of $2,000 per month. Is this wise according to the chart? So what we want to see is what percentage we should be having our budget for housing. It says our budget for housing should be 31%, no more than 31%. So if we take 10,000 and multiply that by 0.31, which is 31%, what would we get? Well, we would get 3,100. And since the budget would be 3,100, spending $2,000 a month is wise. Okay, let's now talk about the 5-number summary. The 5-number summary and box-and-whisker plots. So the 5-number summary of a data set consists of the following values: the smallest number in the set, also known as the minimum, the median of the lower half, known as quartile 1, the median of the entire set, known as quartile 2, the median of the upper half, known as quartile 3, and the largest number in the set, which is the maximum. So what we can do is take this 5-number summary and build what's called a box and whiskers plot. So we would have a whisker for the minimum, and then we would have a line, and then another line for quartile 1, another line for quartile 2, another line for quartile 3, and inside, between quartile 1 and 3, we have a box. Try that again. And then we have a line that goes out to the maximum. So there are our 5 numbers, and that creates the box and whisker plot. Now, it's not always going to look symmetric or perfect, like, and this one doesn't look perfect, but it wouldn't always look. Example number 5. We want to find the 5-number summary and draw a box and whisker plot to represent the data below. 50, 61, 72, 75, 79, 79, 121, 142, 147, 150, 228, 240, and 550. And these will all be represented in thousands because we're talking about home sales in this particular example. It's all money, but that having the thousands there doesn't make that much difference. What we do want to do is we want to compute the 5-number summary. So the first thing I want to do is I want to put an index or number these values. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So our n is equal to 13. Okay, so our minimum is our smallest value, which is 50. Q1, we'll just write median instead of Q2, Q3, and then max. The maximum is our largest value, which is 550. Okay, and our median, we have 13 total values. So we look for 13 plus 1 over 2. 13 plus 1 is 14 over 2. So the seventh value is going to be the one that represents our median. Okay, so our median is 121. To find Q1 and Q3, we'll include the median in this case and look for the median of the lower half. Well, there's 7, so it's the 7 plus 1 over 2. 7 plus 1 is 8, over 2 is 4. So we're looking for $75 there. And also the same is true for the upper half, 7 through 13. We want the middle value of all of those, which is the 10th one, which is 150. Now that we have our 5-number summary, let's put. Okay, so here is our number line with values in the thousands. So our minimum is 50,000 or 50. So we want to put our first bar there. And then our Q1 is 75, which we'll put a line between those two. Our median is 121, so just a little bit less than 125. Our Q3 is 150. And so from Q1 to Q3, we can draw our box. And then our maximum is 550. And we can draw a line from the edge of the box to our maximum. We'll redraw that. Okay, and that is our box and whiskers plot. So we have the minimum right there. We should put the arrow elsewhere. That's the minimum. That's the median. Oops, sorry, not the median. That's Q1. This one is the median. This guy here is Q3, and this one is our maximum. Okay, so that tells us a little bit about the way our data is distributed. Notice that most of our data is way down here, and then we have this outlying value way to the right. Okay, let's answer a couple of questions. What percent of the data values are below the median? Well, this is going to be true for any distribution. The median divides it into an upper half and a lower half, which means there's 50% below the median. Okay, question for part B. What percent of the data values are at or below Q1? Well, this is the same thing. Q1 represents the first quartile or the first quarter. So that means that Q1 is 25%. Okay, part C. What percent of the data values are above Q3? Well, again, that's the third quartile, so there's one quartile above that, which means there's 25%. And finally, our last question is, what percent of the data values are between Q1 and Q3. We'll go back up to our picture here. From here to here, this is the first quartile, this is the third quartile. So we have two quartiles in between those, which a quartile is 25%, so two quartiles is 50%. Okay, that is the conclusion of stats number 4. Please let me know if you have questions as you go through your homework.